Hello again friends. So far we have completed the lock variable synchronization mechanism and the strict alternation solution. In this session I am going to demonstrate the strict alternation synchronization mechanism using the C# programming language. So here is the Visual Studio. You can download the Visual Studio from the Microsoft website and use it for the trial period. So I'm going to create the new project here and just search the C# console application. So here I'm going to select it and click the next. Let us give some name to our project, Strict Alternation Mechanism. Implementation. So the project is getting created. Alright. So here, to understand the strict alternation solution, I am going to make use of the threads to execute some piece of code concurrently. So what I'm going to do, I'm going to take one global variable and that will be shared among the two threads. So let's define some global variables first. Let me just put a comment, that is share variables for two threads running concurrently. So as we learned in the strict alternation design and implementation in my previous video, I am going to create first an integer variable called as turn, which is initialized to 0, let's assume. And when you initialize to 0 means the process, here the threads, here the one of the thread is going to start the execution whose turn is 0. Eventually when I'll complete this program, you will understand it. So before I write something in the main, let me create the two functions. The function 1, I will call it as a generator function, which is executed by thread 0. Let's assume that. And let us implement some of the logic in the generator function. Let's assume that this function generates random numbers. I will call them as items one by one. Remember that I want this function, generator function, to generate the random numbers one by one. Means after the generation of the first item, other function I am going to write, that is a consumer function, which will consume the item first, and then only the generator will be able to generate the next item. Alright, so I want these two functions to do their task on a strict alternation basis. So here is the function, I'll call it as a executed by thread 1. Alright, and here I put the comment, this function consumes the items generated by the generator function one by one. Alright. So for that, let's assume that the generator is going to generate the n number of items. Let me initialize n to some value, let's say 20. And I'm going to take one common buffer, that is also the shared variable, in which the generator will put the items and the consumer will consume from the same buffer. So here is the array of n of size 20 I have declared. Now here, remember that turn, n and buffer are the three global variables. Now let's complete the function generator. So in the generator, what I'm going to do is, first let's put a printf statement. In the C#, you can have this kind of statements such as system.console.writeLine. So that will write something on the console, just like a printf statement in C or C++. So what I'm going to write here is generator function started. Alright, so whenever I am going to call this from the main, that will get start, and at the same time here I will write the another statement that will print the consumer function started. Alright, let me complete the code of generator first. So in the generator, what I'm going to do is write the for loop. Let's declare an integer starting with value 0 and I less than n, that is 0 to 19, that is 20 items are will be produced, and I++. So here's my entry section. As we learned, I want first the generator to produce the item. Okay, so now I'm going to write the logic of the entry section. Turn is not 0. If the turn is not mine, let's consider that the turn is not 0 means 0. When the turn is 0, it is generator's turn, and when the turn is 1, it's a consumer's turn. So what condition we will write in generator? If the turn is not mine, do nothing. Alright, I don't want any code here. You can just open and put the open and closing braces here. Instead of that, you can just put the semicolon here, indicating that this is going to be the busy loop statement. And then I'm going to write the critical section code. In the critical section code, let's generate some random number. So here I'm going to first give one printf line, that is write line. Generating element number, and let's give the I value. Alright. So I come to know that I'm just going to produce one item here, generate one item, and let's write some code here. So let's say I'm going to make use of the random class in the C# is equal to new random class, and I'll say the in the buffer, I can update the spelling here, buffer. So in the buffer, I am going to put the item, so in the buffer, let me copy the buffer, and so in the buffer at the position I am going to put this r dot some random number. Alright. So once I put some item in the buffer that is ready for consumer to consume, and that's how I have to give the turn to, so I'll write here exit section of the synchronization mechanism, and I'm going to set the turn equal to 1. So with this piece of code, I make sure that 2 items are not generated consecutively. The second item will only be generated when the consumer consumes the previous item. Alright, so similarly, I'm going to write the code in consumer also. So the same logic I'm going to copy here and in the consumer as well. So here entry section turn. So I'm going to change the value here. When the turn is not mine, wait. Alright. And the critical section is consuming element number I. And instead of that, what I'm going to do is take a local variable integer item is equal to take the item from buffer. Oops, sorry, it should be I. Alright. And what I will do is I will also print the value of buffer also, the item also. So what I'm going to do is print the value of the item. Generated item Alright. So I'll come to know that the item is generated and what is its value. Alright. And similarly, I will give the printf write line statement here. Consuming item, and let's print the value of that particular item. I'll just put the new line character so that it will be useful to identify the differentiate between the output on the console. Alright. So, and after the consumption of the item, we have to give the turn to, so I'm going to change the turn here to the generator. Alright. So let me put the comment here. If turns current value is 0, it's generator's turn. And similarly, to understand it for the consumer, if the turn's current value is 1, it's consumer's turn to read the value from buffer. Alright. Okay, so my two functions are ready, generator and consumer. And now let's go to the main. So here I will write program started. In the main function, what I'm going to do is create two threads. So thread is a class in C#. Let me say T0 is equal to new thread, and I have to tell this thread that I want this thread to execute this function. So I have to just supply the name of that function. Oops, you don't have to provide the as a string, yeah, just the name of the function. Alright, and here is the second thread I'm going to create. Just let me just copy it, and let's say the thread 1. And the thread 1, I want the function consumer to start the execution. Okay, so here are the two objects of the thread class, and start the threads concurrently. So I say t0 dot start and t1 dot start. So the start function of the thread class is going to start the execution of both the threads concurrently. And once they complete their execution concurrently, both the threads, what I'm going to do is wait in the main function so that I come to know that both the threads have completed their execution. So let's wait for both the threads to complete their execution. And how can you do that? You have to just say t0 dot join. Join is a function which checks whether the execution of that particular thread has completed or not. And finally, I'm going to write print something on the console that both the threads have completed execution. To just hold the screen of to hold the console screen, I'm just going to write console.readline. I can say read key. So this will make sure that the console window will not exit without our action. Alright. So that completes my program as such. Let me walk you through the program. First, we have taken the turn variable, which will decide whose turn it is to enter into the critical section. If the turn is not 0, means this will wait. And if the turn is not 1, means this statement is going to make this thread wait. Here is the critical section. In this critical section of consumer, I am going to take the item from buffer. I have put some printf statements here and give the turn to the generator then. And the opposite logic in the generator, it will in its exit section, it will give the turn to consumer function. Alright. So let us execute this program and see the output. So let me save this program and run it. So it is getting compiled. And here is my output. So what is the output? Let's see. If I go to the start, program started, consumer function started, and generator function also started. So both the functions have started as of now concurrently. So the first statement is generating element number 0. So definitely it is the the program counter have entered in the generator function and generated this particular item. So this item is generated. So what is this item? I will just remember the last few digits, 616. Alright. And then it is a consumer's chance consuming the element number 0, and the same item from the buffer is getting consumed. You see the same number. Next, the generator is going to generate the item number 1, and then the consumer is going to consume the same item from the buffer. So you see the generator and consumer are doing their execution in a strict alternation basis, generating consuming, generating, consuming. And here is my total output. And at the last I can see the statement, both the threads have completed their execution. And press any key to close this window. So let me just give some any input and the program has exited now. Alright. Let's do one thing. Let us take out this entry section code. Let me comment it and see how this program will behave now. Alright. So I am not restricting these two functions to enter into the critical section. So they can enter anytime. Alright. So let us just comment this entry section and exit section code. One more time I am going to save it and run it. You see, this time I can alright, here is the output. So program has started, consumer function started and generator function started. So consuming the element number 0, and you must have observed the first statement itself is consuming the element number 0 before the generating element number 0, then the consuming item 0. So this consumer has started consuming the item 0. You see, the next statements are consuming element number 1, consuming element number 2, and before that I cannot see the generating element number 1, generating element number 2. So if you observe carefully, up to this line, consuming element number 4, I don't have the numbers or the items present in the buffer because generator has not generated them yet. Alright, so this is not behaving as expected. You see, consuming, and somewhere in the middle again generating. So I don't see the strict alternation between the two jobs here. Let me exit this program one more time. Again, let's uncomment the code. I want the strict alternation, that's why I have to wait and then give the chance to other thread. Alright, so let me execute it one more time and see the output. Yeah, now I can see generator function started, both the functions have started, but the first statement which is there is the generating element number 0. Here is the element generated. Then the consuming element number 0. Here is the item. Generating, consuming. You see, it is guaranteed now. If you go down, it is guaranteed that consuming, generating and finally consuming. And both the threads have completed their execution. So that's how, with the help of this simple logic, we have made sure that these two threads, even if they start concurrently, they will do their job on a strict alternation basis. This I have explained with the help of threads within a program within the same process. Threads within a same process can execute some piece of code concurrently. So this piece of code and this piece of code concurrently. And with the help of this entry section and exit section code, I achieve the mutual exclusion. You can also write this same logic if you want to synchronize between two different processes itself. Alright. In my next few videos, I will explain how exactly we can synchronize between two different processes altogether. But our logic of entry section and exit section is not going to change. And that was all about the demonstration of strict alternation solution using the C# programming language, you can implement this strict alternation mechanism in any programming language such as C, C++ or Java. The strict alternation mechanism guarantees that two multiple threads or processes. In this demonstration, I use the threads to do some two tasks concurrently, and where we prove that with the strict alternation mechanism, the two threads running concurrently will perform some job in a strict alternation basis. Thank you for watching this video. If you have some doubts or questions, you can put in the comment box.